So to run analysis, let's run, let me categorize these into, I want to say 2 or 3 different sections of analysis. You have some mechanical based FEAs like harmonic vibe, ICT, mechanical, natural frequency, and random vibe, that when you run any of these, Ansys Mechanical and the background will run the analysis for us. On the other hand, we have some other analysis like solder fatigue and plated through hole fatigue, that these are just calculation based. So when you run these are really fast. You run some calculations and gives you the result. So now let's run mechanical shock. Right click, go to edit properties or run analysis task. These two will take you to the same window. You need to define some analysis properties, right? And then you'll need to define the events or loads that you want to consider for this analysis. So we have multiple different or 2 different mechanical shock in our life cycle, but I'm only interested in one of them, which is going to be the operation, which is the initial pumping start. And then you will define your mesh properties. So for example, in the PCB modeling window, I will change the merge to bonded because bonded will run a little bit faster. I want to increase the mesh size here to run this quickly. Usually 10 is pretty huge, but for this example, I think it'll be okay. And then you have to go through this list and see what you want to include in your analysis. So in this scenario, the trace modeling is disabled, mount points needs to be enabled to run this analysis. Drill holes are disabled, part modeling is enabled. So here you can define a filter. So what is the minimum part size that you want to have in your analysis, right? In this scenario, I want to say just ignore anything that is less than 5 millimeters. And I want to increase the max mesh size to 5 to run this faster. Lead modeling is disabled, wire bond is disabled, piloting region disabled, and mechanical part disabled. Save and run. Let's run natural frequency, right click, edit properties. Once you define those properties in one of those mechanical based models, it will save that window here. So you don't need to change anything, just save and run. Let's run random vibration, edit properties. If you want to run it in all X, Y, and Z, or just one of them, let's just run in all of them. Why not? Save and run. And then we can do solder fatigue, edit properties. Again, you fill in a analysis properties, which I don't want to change anything here. And then you choose the thermal event of your choice. I will choose the pumping, which was the harsher kind of a solder fatigue, or harsher kind of a temperature cycling. Save and run. Let's run plated through hole fatigue as well. Why not? Edit properties. Again, they share the similar windows here, the thermal events, but then different analysis settings, which we don't touch. We just keep it as is. Save and run. Once any of these analysis is done, you either get a question mark or a green check mark. If you have a clock, that means that analysis is running. So now let's double click on solder fatigue. So for all of these analyses, we get a summary tab, which will show you that how many components for that analysis are in low risk of failure, which is green, high risk of failure, red, and moderate risk of failure, yellow. And then we have the life prediction curves. So this black box you see here, 4 years and 3% probability of failure, this is what we defined earlier on in the life cycle. The red is the calculation. So if the red comes out of the box anywhere on top here, it's not good. So you can see that this is failing at less than 2 years. If it comes out of the box here, or anywhere actually out here, it's good. And then we do get a table for solder fatigue, which shows us the time to failure and cycles to failure for each individual component. And you can see like U9 and U10 here, 7 years and 11,000 cycles. If I go down to somewhere in the middle of the list, you can see This R147 has 22 years of life and over 33,000 cycles. And also, you can right-click on any of these components and view the life prediction for that individual component. Now you can see how much U9 is contributing to our analysis. Or if you want to see a combined bunch of these components, just hold your Shift key and then right-click and view life prediction, and you can see how much all these components together, and the short list is shown here to your life prediction curve. Next, you can see the random vibe. Again, a summary tab, green is good, red is bad, yellow in the middle, a life prediction curve. So you can see here the calculation is all flat, right? This means that we don't have any problem here. And if you go to the table, we can see everything is green and looking good. We have plated true hole, which again, we get a summary and life prediction curve and a table, which is similar to what we had in solder fatigue. The natural frequency, you can see the first mode at 191 hertz and mode 2 at 399 hertz. And mechanical shock, it's all green as well. So it's all similar to the other analysis. And then we have these life prediction curve, which will show us the combined life prediction curve, which is the yellow, the red one. And then you can see that we have the plated true hole fatigue is the green one. The blue one here is the solder fatigue, and both mechanical shock and random vibe is on top of one another, which are good. And on the top here, we have the scorecard for all of our analysis that is listed here. So these are all good, pretty pictures that you can put in your presentations.